first. So this is 10.3 number 33, which no one asked about for the record. But I'm doing it because I drew it up here. So here's a picture where there's two functions, f and g, which I really should have used my multicolored pen for. And I'm supposed to think about... See, I told you, no one asked about it. Just because you didn't have to do it doesn't mean this can't be a learning experience.
I agree, sorry.
Okay, so we're supposed to think about h of x is f of x minus g of x. Right? And I'm really supposed to sketch a picture of this. Got it?
Yeah.
So, how about this? When is h of x minus, or when is f of x minus g of x 0?
Wherever they intersect. Yeah, wherever they intersect.
Yeah, when they're the same, right? If you take something and subtract 7 minus 7, you're going to get 0, right? So like here, 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 and here, your new function h is going to be 0. You see that? So if I'm plotting dots, I know that here there's a 0, and here there's a 0, and here there's a 0, and there's a 0. That's the x-axis.
Yeah.
Right? Okay, now in this little bit, which one's higher, f or g?
F.
Pull it back. Yeah, I think that's f is higher than g, and so your function h is going to be positive. So I know that in here at least I'm positive. In here, which function's on top?
G is on top.
G's on top, so h is going to be negative. In this interval, f's on top again, so that's going to be positive again. Here we're going to get negative, and over here, positive. It's like it changes every time, but it didn't have to. So if I had had a picture where I had f like this and g like that, and it didn't necessarily have to change just because they touched.
Fair.
Let's call that.
Tangential.
It is tangential. Nice. How about in here? How big is this? How big is h in there?
That's all like y-axis?
Yeah, like what's the output? Should be the difference between the two things, right? So how far apart are they?
Oh, there's no g, so it's like that.
Well, yeah, g kind of went off the picture, right? So this height here should be the function value. You guys see that? Like that distance there is how far f and g are apart. And that's what h is recording.
Okay.
So my dot for, and that wasn't supposed to be coincidentally the same height, but it was. In here, they're not very far apart, right? So I get a dot that's not very high. It looks like they get further and further apart, so probably this does something like that. You see that? Like they're really far apart with f on top, and then they get closer and closer together until they touch. And then what happens?
Go off in different directions again.
Yeah, they go off in different directions again, so they should get further apart, right? Which means that h should get bigger.
Yeah.
Well, in this case, it's getting bigger in the negative direction, right?
Yeah.
So how big does it ever get? Like, where's the biggest h ever get?
Second interval. Oh wait, no. That's
Like
biggest
in this interval,
That's in absolute value.
like in the middle, like here, that's the furthest apart those two things ever get?
Top of the crest.
It looks like they get furthest apart like here or something, right?
Exactly, top of the crest.
Yeah, it's maybe not quite the top of the crest. It's probably just a little bit before it because this thing's going up.
Right.
You guys see that?
There.
Kind of tough. But you take that distance and you bring it down here. Got it. So you're going to get something that looks like this.
What? Why did that?
What is this? What number is this? 33? 10.3?
So this is recording how far apart are they?
Oh yeah.
You guys see that? So if you took this whole stack of little distances, right? You've got this whole stack of distances. If you pushed them flat, you'd get some kind of blob, right? My blob's a little bit dorked because it should be a little bit off center. It should be like a little bit fatter on this side and a little bit skinnier on that side or something.
Yeah.
You guys see that?
I totally understand.
That's just taking this whole set of green lines and then
Oh, turning it into h of x?
pretending this is the x-axis and just dangling them from that x-axis. Right, so I took this line here, which I'll call star, and I took it and dropped it right here. So that line right there.
Yeah,
And I took maybe this one here and I put that one there.
and you're graphing h of x.
Yeah, I'm graphing the difference between
Mm,
f and
I
g,
understand.
right? And so the difference between f and g is the distance that f is above g. In this case, there g is actually on top, and so I'm getting negative numbers out.
Makes sense.
All kind of with that. Okay, how about in here?
What was the evil?
Well, it's positive, so you make it flat and then you go up, right? Or something.
Okay.
So you find the difference between them vertically.
Right.
Yep, so
And
I
you
find these little vertical distances,
And then
right?
from the base, from x, yeah, you just go up that amount of vertical distance.
Yep. So I'm going to get something that looks roughly the same as it did here.
Exactly.
Why does it look roughly the same?
Because of the distance.
Yeah, because that one's almost flat, right? And then in here,
Alright, well, now it's negative.
yeah, it goes negative, but it's not very much because they're pretty close together there. So you get some kind of little shallow business. And then on the other side here,
So then I said diverging crazy
Positive,
directions.
yeah, this gets positive and giant fast.
That was
Yes,
so
that-
much fun. It's like a roller coaster.
It is like a roller coaster.
Cool.
Cool? Questions?
So is that like what the, so what is,
What's the difference?
So this was me making the difference out of the graphs of two functions, right? So I took a graph for f and a graph of g, and I made a graph for f minus g. That's what this green thing is. This is how different are f and g.
so let's say we're using that in like real world, like,
Yeah, so a good real world example of this
right? 'Cause-
would be something like if we took our revenue
right.
and subtracted our expense. You have revenue minus expense, what is that? Profit. And so we can notice something like, okay, like that wasn't good.
Right.
Things recovered a little bit. Then we had another little wobble, but it wasn't nearly as bad as the first one, right? Like this is a big hemorrhage of cash. This is just like a, oh, whoops, bad quarter,
And then.
right? And then, sweet, right? We figured this shit out.
Mhm.
Cool. Okay, so yeah, that's like what they use, like for like to find volume in like shares, right? Is
Yeah, so one thing I could do is I could say, okay, so between, say, the beginning of this recession and when I figured stuff out, how much money did I lose? Well, that would be this, it counts as negative, and then there's this area here that counts as positive, and then there's this area here that counts as negative.
sweet.
So it looks like I'm making a net negative. So I lost money over the course of my recession, right? And how much is just the area of this plus the area of that minus the area of this. You guys cool with that?
That makes sense.
So that's that area under the curve thing.
Yeah.
That's called an integral.
An inter what?
Integral.
Integral.
Integral?
Doesn't that also mean like an integral part of this operation?
Yeah, like a crucial part.
Yeah,
Yeah.
Cool.
They're pronounced differently. Integral,
yeah. And integral.
integral.
Yeah.
Yeah.
Okay, interesting.
Welcome to English, sorry.